So let us recall what we have did into the previous lecture. In the previous lecture, we have discussed about the metric on any arbitrary set. So to define a metric, you required one non-empty set X, and you required one function which is defined on X cross X to R, which satisfies certain conditions. The first condition is d of xy is greater than or equal to 0. D of xy, second condition is d of xy is 0 if and only if x is equal to y. D of xy is same as d of yx. For this is true for every xy and z belongs to x. And the third condition is triangle inequality, that is d of xy is less than or equal to d of xz plus d of zy. The first one is called the non-negative condition, third one is called symmetricity, this one is called triangle inequality. And we have solved, or we have seen lots of examples which based on this metric, and I can say the x comma d is a metric space and d is a metric on it, and we have seen the lots of examples based on this metric. If I can say that in short, we have talked about Rn. So Rn is a space which is the n-dimensional space, and on this we will define this metric which is summation I running from 1 to n mod of xi minus yi raised to p whole raised to 1 by p for p greater than or equal to 1, where this x bar is x1, x2 up to xn, and y bar is y1, y2 up to y. You can have the same definition for infinite sequence also. Suppose you have a sequence, set of all convergence sequence or set of all sequence, and same way you can define a metric on a set of sequences. In that situation, this summation is running from 1 to infinity. In that case, this summation should be converged. If that converged, then we can talk about the metric on set of all sequences also. Okay? That is one of the idea you can deal with. That is called sequential space, and on a sequential space you can define a metric. The another examples that we have taken is Cx, that is a set of all continuous function, or I can say Bx or B01. I should not write x here, so it has to be C01 and B01. On B01 we have defined a supremum norm, that is mod of fx minus gx, which is the distance between f and g, where x belongs to 01. This is the metric we have defined on B01. So the same metric will applicable for C01 also. And on C01 we have defined another metric which is integration from 0 to 1 fx minus gx dx, d of f g equal to this. This is another metric we have defined on it. So hence, these are the examples we have discussed in my previous two video lectures. And now, here in this lecture, we will define certain object which will be useful to develop the concept of analysis. The first things that we can discuss is what will be the distance between, or how we can define a distance between some set A, which is a subset of a metric space X. So what I am considering, X is a metric space and A is a subset of X. Let's say A, small a, is a point in X. So now the question is, what will be the distance between the set and this point A? So can anybody have any idea regarding this? Anybody have to say something on this? How to define a distance between a set and a point?
Sir,
Yes.
hello.
Yes,
Sir,
yes.
can we do it like this? First, we find the set of all DAX where X is in A, and then we find the infimum of that set.
Yeah. So the same concept you are also using in your geometry or Euclidean space. Suppose I have given you one line and there is one point. How to find out the distance between this point and this set of points on a line? We know it is a perpendicular distance, which is actually a shortest distance from that point to on a line. The same concept is applicable over the plane. If you have a plane, if you have a point, how to calculate the distance between point and a plane? So the same concept will applicable there. And using that idea, so it is a shortest distance. Shortest distance means whatever the infimum between this set of all points and this point. So what we will calculate first, as someone says, that you define the distance between X and A, where all X is in A. We make a one set of this and take the infimum of this set. So infimum of distance from X to A such that X belongs to A is gives you a distance between a point and a set A, and it is denoted as d of A small a. So it is a distance between a point and a set. So this is the notation for point denoting a distance between point and a set. Okay. So this is the definition. So I should write the definition in this manner. Let X be a non-empty set. You require a non-empty set with metric on it, that is D. Suppose that A is any subset of X and small a belongs to X, then the distance between X and A is defined as d of A is equal to infimum of d of XA, where all X belongs to A. So this is the definition of a distance between point and a set. Next concept that we like to define is the diameter. like a diameter of a circle. So how you will define a diameter of a circle or of a sphere? So I have any set which is given to you A, which is a subset of a metric space. Can we define a diameter of that set? In general, any arbitrary set is given, then can we define a diameter of that set? The question is, what will be the idea? How we can define it? I'm giving you a hint. You just look at the diameter of a circle or a sphere. How you are defining a diameter of a sphere or a circle? So using that,
Sir, in circle we take the length
which length you are taking?
of the largest chord.
Of the largest chord. So it is actually, can I say it is the a longest distance or maximum distance between any 2 points on the circle. So what you are taking, suppose this is the circle,
Yes.
and it does not look like circle, but you can assume that it is circle. Okay, and you can, this is the center of that, and you can draw a diameter. Let's say this is the diameter. Then what is actually a diameter? Diameter is the length of the longest chord. But what is actually longest chord? Longest chord is actually a maximum distance between any 2 points on the set on the circle. So the same concept we can apply here, and we can define a supremum because it is the longest distance. So here we have a set, so I can define as a supremum of a distance between A1 and A2, where A1 and A2 belongs to A. Obviously, the concept is required for that. It is let X be a metric space. With metric D, this is required, and A is a subset of X. Then the diameter of A is defined as this supremum of, and it is denoted by D of A, the diameter of the set A. Okay, so this is the definition of the diameter of a set A. Here one should note for things that we are assuming the diameter of empty set that we denoted as phi is minus infinity. This is our assumption. So where phi is an empty set. So this is our assumption that we are taking, that the diameter of empty set will define as minus infinity. Next is very important definition, that is the open sphere. So what is the definition of open sphere? So obviously you require let X comma D be a metric space. You require first, if you want to define a open sphere, you require one metric space on that set X. And you require one point A, which is in the set X, and which is always possible because X is a non-empty set. So that's why there always has one point in it. And I'm taking, also I required that R greater than 0. That is the first one real number, which is a positive real number that I need. Then the open sphere should not be the open sphere, because there are many. Sphere is defined as set of all points such that distance between this x and a which are less than r. Okay, if you can see in the plane or in R2, then if you are, this is your set x and this is the point A. So what I have said here, it is a set of all points which are less than, set of all points which are having the distance between this x and a is less than r. So all those points which are inside this area, and this is the quantity, we can say it is r, and this is the a, and it is denoted by SR of A. This is the notation for open sphere. Here, this A, it's called the center of the open sphere. What is this called? The center of open sphere. And this R, it's called the radius of open sphere. Like a circle, sorry, disk, open disk you have in R square, if you can consider, then it is like a disk in R2. The center is there and radius is there. R2 with usual metric. Okay, if you change your metric, because we have seen that lots of metrics are defined on a set. If you change your metric, the open sphere will be different. Let's see, that is the things. Before that, I want to note here that an open sphere is always non-empty. The first note we should write is open sphere is always non-empty. Why? Because here your R is greater than 0. So this distance is always, there is one point is there. That is, the center is always there. Okay. So we can say that because the sphere contains its center, the center always will be in the sphere. It should not be outside the sphere. Okay. And it is always there. Let us have the examples. The first, let's say, talk about the examples here. The first one, I'm taking x is equal to r, which is the usual real number, and with the usual metric on it. When I say usual metric, it's always a usual thing, that is mode of x minus y. For every xy belongs to, this is usual metric on R. When I say usual metric, it has to be this. Then what will be the SR of A? Let us see by definition. By definition, it says that set of all point in R, that is your x, such that distance from A to x is less than r. This is the definition of open sphere. But what is this d of ax? D of ax, according to this, it will be mode of x minus a, which is less than r. And what is mode of x minus a? which is less than r into in a real line that we know it is your r is between minus, sorry, your a minus x is between minus r to r, and if you can add so it is better to write down this is x minus a. Instead of writing a minus x, I should write this is x minus a. Now, if you add a from this, then you will have it is a minus r to x, a plus r. So what is this? This is actually an open interval, that is a minus r to a plus r. What is open sphere? It is actually a neighborhood of a with radius r. So geometrically, if this is your point A, then this is a minus r to a plus r is the open neighborhood or open sphere of this point A in R. So I can say an open sphere in a real line is an bounded interval. Okay, so that we can write down as a conclusion. Therefore, an open sphere in a real line is an open bounded interval. Let's have the another example, second example. Let us consider x is equal to c, that is set of all complex number with usual matrix. Usual matrix means I will take the z1 and z2 such that mode of z1 minus z2 is there. For every z1, z2 belongs to this set C, set of all complex numbers. Let z0 belongs to C and r is greater than 0. Then what will be this SR of z0? As per the definition, this is set of all z belongs to C such that distance between z and z0 is less than r. So as per this definition of D, we can say that it is mode of z minus z0 less than r. But what is mode of z minus z0? You know that if z1 is x plus iy1 and z2 is x2 plus iy2, then mode of z1 minus z2 will be x1 minus x2 square plus y1 minus y2 square is there. If I take the square both sides, then the square root will goes away. So it is mode of z1 minus z2 is square root of this quantity. So according to this, if I can assume that this z0 is x0 plus iy0 and z is x plus iy, then this is set of all z in C such that mode of x minus x0 square plus y minus y0 square less than r square if I take the square both sides. And what will be this represent in geometrically? This will represent a disk with center x0 y0 and the radius is r. So that is the points which are inside this disk. It is represented by this open sphere. So I can say an open sphere in C is a disk with center z0 and the radius r. In short, we can write that. Fine, let's take the another example. Third one. Let us consider x is equal to r square. And the distance between x bar and y bar as a point of r square we define as maximum of mode of x1 minus y1, x2 minus y2, where this x bar is equal to x1, x2 and y bar is equal to y1, y2 belongs to r square. Both the points are in this. And for understanding, I'm just taking r is equal to 1. So for timing, I'm taking r is 1 and x0 as 0, 0. That is the origin I'm taking. Then as per the definition, what is the open sphere of 0, 0 with radius 1? As per the definition, it is a set of all points in R square such that distance between this x0, that is 0, 0, and any point in this space R square is less than 1 due to R is 1. Now what is this distance? Let's say this is, as per the definition of metric, this distance is maximum of modulus of x minus 0, because x is here minus 0. So it is x minus 0 mod of y minus 0 less than 1. So that's why it is set of all points in R square such that maximum of mod of x comma mod of y is less than 1. So this is the definition, or this is the way to represent this open sphere of 0, 0 with radius 1. What is this geometrically represent? Can somebody tell me? Can somebody visualize what will be this as a geometrical? If I can draw, this is your y-axis and this will be your x-axis. What is this says? It says that set of all points where the maximum of mode of x less than 1 or mode of y is less than 1. So mode of x is equal to 1 represent this two lines. X is equal to 1 is this vertical line minus 1 and this is the vertical line. So it has to be straight line I should draw. It's not look like straight. This is your x-axis. If I draw a straight line, this is the x is equal to minus 1 line and this one is x is equal to 1 line. And this will be the y equal to 1 line and this is the y equal to minus 1 line. Just make sure this is the square. And this thing is actually represent inside portion of this plane. The boundary is not included. Whatever the portion which are inside this 4 lines, this is the representation of S1 of 0, 0. So it is the, actually I can say in general, it is a square, inside portion of a square without a boundary. That's represented by, see in the art square, this is the one of the open sphere. The third one, sorry, fourth example that we will take with R2, also I am taking the same with R2. But here I am changing the metric, that is d of x bar y bar. I just take the metric as mode of x1 minus y1 plus mode of x2 minus y2, where this x bar is x1 x2, y bar is y1 y2, both belongs to R square. Here we are defining this is as a metric. I am taking a center, that is x0 is 0 0 and the radius is 1 for understanding the concept. So what is S1 of 0 0, or I can say what will be the open sphere at center 0 0, radius is 1. So as per the definition, all x belongs to R square such that distance between x bar and 0 0 is 1, is less than 1. So that is all x belongs to R square such that according to the definition it is, let's say x bar will be xy, then it is mode of x minus 0 plus y minus 0 less than 1. And what is mode of x minus 0, y minus 0 less than 1 represent?
Square of side root 2.
Yes. So it is mode of x plus mode of y less than 1. Then according to the, this is your x, y axis and x axis if I consider. What will be this? If you have done your operation research course, then probably you know that it is the 4 lines, that x plus y less than 1, constraints, that is x minus y less than 1, minus x minus y less than 1, and minus x plus y less than 1. These are the 4 constraints are there. And what will be this 4 constraints represent? It will represent the 4 line. The first line is here, the second line is this is the third line, and this will be the fourth line. And this region is actually inside portion or inside quantity which lies in this square. Okay, so that is the all the points which are in this without boundary. It's represented by open sphere. See, so what is my objective here? And the fifth example that I can take is with the same space x bar and y bar I just define as usual manner, that is the square root of x1 minus x2 square plus y1 minus y2 square for all for x1 minus y1, as if I define as the similar way we have defined the previous one, x1 minus y1, x2 minus y2, then x bar is x1 x2, y bar is y1 y2, where x belongs to R. If you consider your x0, that is a center, as 0 0 and the radius is 1, that can somebody tell me what will be the S1 of 0 0 in this case? So it is a set of all x bar belongs to R square such that, yes, it is x minus 0 square plus y minus 0 square. If I can say this x bar is xy, then it is x square plus y square less than 1 because we have taken the radius is 1. So this is less than 1. So what does this represent? It's represent a disk with center 0, 0, radius 1. So ultimately, what is the objective? We have the same space here, but on the same space, we have three different metric we have defined in the previous league. That is the first one, we have defined this maximum. In that we have open sphere as a square, this type of square. The next one we have defined this is as a metric. In that we have got this type of square. And the third one that we got this one, and in that case we have seen that is as a disk with inside portion of that. So there are three different metric. You will have three different metric on it. You will have the different open sphere on that set. So that is the question. What will be the relation between these three? The first one is this, the second is this, and the third one will be this. What will be the relation between all the three? That I'm giving you as a question. That what will be this? You can find out and think for that. Which one is a subset of other, or which one is a bigger, and that will leads you one of the important concept for your higher study. Okay, and this topic is actually discussed in nonlinear space also. What is the nonlinear space? That I have already talked in the previous one of the lecture. So you can just go through it, and it will lead to very interesting analysis that what should be the relation between these three open spheres. And there are many open spheres are there. For example, if I have this metric xi minus yi raised to p whole raised to 1 upon t, I running from 1 to 2. If I have all the metric I define for this p greater than or equal to 1, and all the value of p have the different metric on this R square, and all of them have the different open sphere with center 0, 0 and radius 1. What are the relation between that open spheres? That you can think for. Here I have discussed only three cases. For p equal to 2 is this case, p equal to 1 in this case, and this is actually p equal to infinitive case is there. That is also one of the important thing that you can see. But so this is the things you can have when t infinitive. What will be the situation? Whether it will be converged, or there are many questions is there. So that is the analysis already is developed. Those who are interested, they can see by their spare time. Now let us talk next example. That is the other metric which we have seen, or metric space, or rather I can say it is a C01. So if we have defined a C01, that is a set of all real value continuous function defined on closed interval 0, 1, and on that set we have defined this metric, that is d of f in fg, which is supremum of mode of fx minus gx for all x belongs to closed interval 0, 1. This is the metric we have defined on it. Let us consider any f0 in x and r is positive. The question is, what will be the open sphere of this f0 into this space? So SR of f0, what will be the SR of f of 0? That is f of d of f comma f0 less than R. So ultimately what will be this? It is a supremum of this two. Or I can say in the other way, it is a set of all f in C01 such that norm of f minus f0 is less than R. The norm is nothing but this supremum of fx. So geometrically what is this represent, or what are the functions will be there? So this is your, let's say, x axis and y axis. Okay, and if this is this 0 and this one is 1, so first of all you require f of 0. Let's say this function f0 is look like this. Let's say this is the f0 function. Then what is this quantity, or what will be this set of points are required? So here this is the function that I am denoting as, which is a parallel function to this. Okay, just bear with me. This is the exactly parallelly or exactly the same figure as this function, this quantity, and the above one is also the same. It's not look like, but it has to be same. Okay, so what is the above quantity? The above quantity is actually f0 plus r, and the below one is a function f0 minus r. So it is the function f0 minus r and f0 plus r. And what is where this f is lies? F is lies any function in between this strip. I can say this is your function f. So all the functions which are exist, or which are you can define, you can like to define over this strip, that is the first between f0 minus r to f0 plus r, all the functions which are there in this strip, they are belongs to this neighborhood. So this is the geometrically the neighborhood of C01 is defined. The radius of this will be 2r, that we can say. So in general, the question, or I can say the objective is to define an open sphere on any, in general, arbitrary metric space. This is the concept of open sphere, and using this definition of open sphere, there is one important definition is constructed, which is known as open set, and we will discuss about the open set here. Yes. Anyone have any problem?